Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
TV world. I'm going to be talking a little bit about a project that we've got going at Michigan called the Connection Project, which is very much a project in sort of an advanced collaborative environment as we've thought of it in the community, at least as I've been involved. I think now we're starting to branch out and look out into more and more technologies. When I started doing work with this community maybe 4 years ago through the ACE Research Group, through Global Good Forum, and through this conference series, which I first attended in Seattle 2 years ago, I guess, we sort of thought of advanced collaborative environments as these really high-end immersive environments that took advantage of technologies like video. High-performance visualization would typically require lots of machines to power it and quite a bit of networking. So this project sort of has its roots in those kind of environments. Today's talk is going to provide sort of a brief overview of that project, and then I'm going to really try to bring up some of the challenges that we face, I think are more generalizable for the ACE community. As this is a workshop, I'd like to encourage discussion towards the end of the talk, so I'm going to try to run through this a little bit quickly so that we can open it up to some discussion and hopefully get some conversation started that we can continue in the town hall that we'll have tomorrow afternoon. If there are any threads that you really like that come up through this or any of the other talks, I'd appreciate it if you could write it on a sheet of paper and hand it to me. I'll be one of the moderators for the town hall session tomorrow. If we can create sort of a list of topics that people are really interested and want to talk about, I think that will help us have a really productive session. So this is sort of a continuing thread. Last year in Nice, I gave a talk that looked at sort of social ergonomic problems in advanced collaborative environments. And social ergonomics is this idea that was sort of pioneered by John Seely Brown and Susan Newman in the mid-'80s, that the design characteristics of a system can have a profound and direct influence on the social behavior that's mediated by that system. Examples are in video conferencing. There's a little bit of delay built in from video encoding and decoding and moving it across the network. And some lab studies have shown that when people aren't expecting that delay, they interpret that delay as hesitation on the part of the other speaker, which then gets attributed as dishonesty, withholding, or lying. So in those sorts of cases, the dynamics of a technical system can really influence the social behavior that happens around that system. In some cases, can lead to profound changes in behavior or breakdowns. In the past year, we've begun a project at the University of Michigan that's been funded by the University of Michigan Office of the Provost to look at some of these issues in more depth, using a combination of laboratory studies to look at some of the design parameters that go into these sorts of advanced collaborative environments, and some of the social issues that surround them, some of the dynamics, as well as sort of some field studies that involve building some of these environments and putting them to use. Now, our intent to do this was to spend a lot of our time taking a very close look at some of these social ergonomic issues. But what I'm going to talk about today are some of the other issues that have really emerged to the forefront of this research as really critical things that we have to address when we're building these sorts of environments. So this particular project, called the Connection Project, links two buildings at the School of Information within the University of Michigan. Now, lots of us here come from communities that are engaged with various cyber infrastructure projects, high-speed networking, high-performance computing, that kind of stuff. And so in many ways, I would expect some skepticism that linking two buildings on the same campus would mimic some of the issues we see in these large, distributed, multidisciplinary projects. But the goal of this is really to take a look at some of these collaborative systems and environments where they're really likely to succeed. To the extent that a lot of these big distributed science communities have been successful is somewhat of a minor miracle, given the amount of issues that come up in collaboration and the number of barriers, which Judy Olson will talk about much more in depth tomorrow, so I won't go into it too much. But the idea here is that we can take the School of Information as sort of a living laboratory where we're having to live with distance, but we don't have quite the same number of social problems arising from trying to merge different fields from different disciplines, being really far apart where we can never travel, but it's definitely a nuisance. The two buildings are about 3 miles apart on the campus of the University of Michigan, so large enough that it really does make a difference. It's about a 45-minute car ride. Backing this up, there's a whole litany of studies that look at the impact of interaction, impact of distance on interaction. Leon Fessinger's study of student housing at MIT found that when people were more than about 30 meters apart, they didn't talk. When they were closer together, they tended to interact a lot more. And that finding has been echoed in studies of engineering firms by Tom Allen's seminal work in the 70s that studied the flow of innovation in organizations. Similarly, Bob Kraut found the same thing in sort of a telecommunications field in the study of the late 80s. So, about 90 feet is all you need to get the effects of distance. You get a real asymptote after that point. So we think that the experience at the School of Information kind of mimics at least a lot of the communication and interaction barriers that we see in more distributed organizations. So prior to this project, there were a handful of really common solutions for dealing with this distance, involving transportation, university bus system and car stuff, putting groups together, using hotel space so people could move back and forth between the two buildings, and some use of commodity video conferencing facilities, which we see here. These are really white rooms with screens that are either too small or too big and cameras that are skewed way off to the side. So we could actually move video and audio between these two buildings pretty well, but we couldn't actually do very effective conferencing. This facility on the left you can see was sort of an ergonomic disaster. It was a really wide table with a camera in the middle on the corner of the room. So it was very rare you got a good shot of anyone in the room. You could get pretty good shots of the walls, but in terms of people sitting around the table, not so much. So one focus of this work has been to do some renovation in these rooms with some higher-end systems. So replacing those big screens or that small screen with more reasonably sized displays, one for video, one for data. And there are lots of things we did to try to make this work really well in terms of approximating eye contact and gaze awareness, in terms of tuning the audio well enough. And then there's also a lot of interesting technology stuff, which I won't go into too much today, but we've got a wide variety of capabilities for moving video, audio, and data between these rooms. This just gives you an idea of the sort of transformations we've been making to these rooms and sort of the target designs. We're looking to support meeting room sort of stuff with these systems with reasonably small groups. Now, I want to talk a little bit about a couple of the R&D areas that we've been working on in depth. There's more of a project overview in the paper, which is in the proceedings. I'm not going to, do a full presentation of that paper, but I want to focus on the things which I think are of particular importance to this community as a group of people who's interested in designing technologies, designing these systems, and putting them into practice in organizations or in distributed projects. The first, I want to talk about some of our usability and deployment focus areas, specifically documentation and user controls. These two problems of poorly documented systems and a lack of training, emerged as a huge barrier to system use. And we found from talking to people, really shaped the use of the previous generation systems, involving what people would use them, when they would use them, under what circumstances they would use them. And in a lot of ways, there were some second-order impacts about how much communication occurred between the two sites. The other thing I'm going to talk about is some user control work we've done, which I think will relate a little bit to what Steve Poltrock from Boeing will talk about tomorrow, in terms of producing a user model for the collaboration rather than simply a system model. I'm also going to talk a little bit about some challenges we've had in trying to define technology and design goals. So walking into this, and I think a lot of collaborative systems that are built in industry or academia, documentation is typically system documentation. It tells you all the features and how they work. In some cases, it is a README file. In some cases, it's Java docs. And in talking to the users of the previous generation system, it was really, really clear that this was not enough, nor was a one-page black and white checklist enough. Our discussions with real live users suggested that they needed pictures, they needed a workflow that they could walk through. they needed to know who to call for help, and they needed to be able to see what it would look like if the system was doing what it could. So we ended up having to spend quite a bit of time producing a number of documentation systems. One sort of a multi-page bound documentation system that described everything you might want to do with the system. This one-page quick start guide, which was heavily illustrated, very different than previous documentation that was in the room, and then also a training video that sort of walked users through the steps. We also conducted sort of hands-on training sessions with some key faculty and staff members, and after talking to people, we understand that this has helped tremendously. And this isn't something we usually talk about in these sorts of communities where we're working on building these systems, producing the documentation. That's not what we typically think about as research. But the impact of this activity suggests that it is something that we need to think about. And the amount of effort that had to go into producing this documentation suggests that there are probably some lessons learned that are very generalizable, and we need to figure out a way to codify and distribute that information to other members of this community. Another area of research was and development was in developing better control systems. Again, from talking to users and from looking at logs and looking at sort of failure cases when the previous system had failed, it was very clear that forcing users to log into a web interface, having to juggle multiple remote controls, or to do really complicated workflows to accomplish simple tasks just doesn't work for users. It's a huge source of failure. It's also a huge impediment to users walking in and using systems. Similarly, integrated control systems like a Crestron or an AMX touch panel can get really complicated really quickly. We're actually working on developing a Crestron touch panel system now where we're doing a lot of prototyping and user testing. But looking at other facilities, we saw a lot of cases where these graphical touch panel systems didn't capture the sorts of workflows people were doing, so they were really hard to navigate. And doing something as simple as setting up a call required going through as many 8 different screens, pressing one button on each screen. So in response to this, we're developing and currently testing a set of custom IR and RS-232 controllers. So replacing that 30-button, plasma screen or Polycom or whatever remote with a simple box that has 2 or 3 or 4 buttons that are well labeled, that when they push it, it executes the common workflow, such as call setup to the other site. So instead of having to pick up a remote control, look up the whatever dialing address of the site you want to connect to and connect to it, or even go to the address book, that kind of stuff, that's reduced to a button push. Same thing with, moving PowerPoint slides back and forth. And like I said, these are currently still in testing, so we're going to be deploying them soon. So we don't have any hard data about sort of the usability improvement or the operational improvement. But this highlights a critical problem of, I think, a lot of these advanced collaborative systems or environments where users are going to be connecting to the same places over and over and over and over, and there's no need to put them through a really complicated workflow when we can basically design scripts that are available at the push of a button that's mounted on a wall or a table to execute that same workflow. So sort of a summary of this usability activity and sort of the lessons learned is this has really been sort of a focus on the additional work or the articulation work that's needed in order to get these advanced collaborative environments to work in a real operational environment. This is sort of highlighting some of the work that we're finding we have to do to move it from the demo room into the conference room. Now, I bring this up not because we had to do work and I'm upset about that, but because this is something that we've known as a problem. Documentation and training is not something we just discovered as an issue, but it's not something we talk about because it's something we code as not research. But I think that we need to think as a community about how we coordinate an organized approach to codifying and sharing the information about how you create these systems effectively so that we can make it cheaper to do, make it easier to do, and in some way possibly even define a research agenda so that we can move this out of the not research category into the research category so that we can get some big gains. And the fundamental problem that this sort of encompasses is right now deployment of these systems is an art, not a science. Now, the next thing I want to talk about is sort of this problem of design goals for advanced collaborative environments. When we were looking at what sort of video technologies we were going to be putting into these systems, we found two schools of thought on video quality. The first school of thought says, a 384 kilobit per second H.264 stream is all you'll ever need. This is the party line of the major commercial manufacturers and a surprising number of people in sort of the higher ed community who are more accustomed to using research and education networks like Abilene. The other school of thought says good video requires at least 30 megabits per second, but you really want to try for 1.5 gig uncompressed HD stream. There was really sort of no middle ground about what kind of video quality you wanted to shoot for, and sort of more troubling, neither side had good evidence to back that up. So in an effort to sort of start breaking into this, we conducted a set of lab studies to examine the impact of various ways to encode video on the subjective perceptions of video quality. And what we found in this case is that both these party lines are actually right. When you're dealing with sort of the typical commercial video conferencing image, which is someone's head without a lot of motion just around the lips, the difference between the 30 megabit stream and the 368 kilobit stream is virtually undetectable. Users could tell that the better one was actually better, but it wasn't that much better. In contrast, a complicated scene like this standard of a sports scene, there was a huge difference. And this is more like what you get for a wide-angle shot like this room or a laboratory where you've got lots of people working at a bench doing small things. In this case, for that sort of low-end video, it's impossible to see what people are doing. The higher end, it really does make a difference. Now, I bring this up because I think the quality study illustrates another problem that we have in designing advanced collaborative environments, which is the design goals and the targets are really poorly understood generally. This has to do with video quality, audio fidelity, I think to some extent screen size, the number of videos we optimally want to be going into a space, probably some of the visualization things as well. And one of the reasons I think this is hard is that a lot of us do come from communities that are high-performance computing communities, that are high-performance networking communities, that are big data communities. We don't have the same measurable performance figures that those communities do. So I think that a workshop like this provides a really good forum for those of us in the community to come together and organize around some sort of grand challenges to really articulate what design goals we want to nail down, what design targets we want to really understand well, and put that out there as a challenge, as a goal that we can all work to. So I'm going to wrap it up and open it up to a little bit of general discussion now. I think we've probably got 5 or 10 minutes. A couple of acknowledgements first. The people who've been involved directly with the project, a couple of graduate students, Rasika Ramesh and Juna Hugh. Also, we had a number of undergrad students that have worked with us. And again, we thank our sugar daddy, the University of Michigan office of the provost. Pete.
So when I go to the doctor or the dentist, they have this pad of workflow buttons, for calling things up in the different, rooms to either call up a chart or to request somebody. And whenever I look at that, I always think, just sort of looks like ancient technology. There are these,
right.
These little cube-looking buttons that have lights behind them, and they are labeled with letters that, unless you had memorized the system, you wouldn't know what it is, CJR or whatever it is. But they all very efficiently use it with sort of the one-click method without going through lots of menus and interface. Are you suggesting that this sort of a workflow-based interface for these kind of interactions is really, we'll get back to that? Because we kind of, it seems like, in the old style, we had stuff like that, and then we've moved away to these complicated menu systems.
Right, and I think it's something that we should shoot for. The danger with sort of like the doctor one is that you get a whole bunch of colors and a whole bunch of different buttons on the wall. And I think that that's happened with the system remotes we have now. So we've gone from shortcuts to mapping each button to a specific function, which gets combined in sequence for a workflow you want to do. And with expanding system capabilities, you have to let people be able to control that. But I think what we've lost sight of is that 90% of the use of a lot of these systems is executing one particular workflow. And in losing sight of that, we've lost a way to effectively shortcut things. We may be able to do it in an interface, like through an address book, but doing that, in the case of setting up a video conference call on a commodity video conferencing unit, the workflow you still have to work through is picking up the remote for the display, turning that on, picking up the remote for the codec, turning that on, figuring out where you run on the menu, doing a couple of button clicks to get to the address book, clicking on that, looking up the thing you want to connect to, which is probably the thing you're connecting to 90% of the time, but it probably doesn't start with A. So you've got to scroll all the way through that, potentially through certain screens, and click on that. That's a lot of steps to have to go through when you're doing that 90% of the time. My dean, who sits on the advisory committee for this project, spelled it out really clearly. He wanted a big red button on the wall that would connect the two spaces. And, we tried to explain to them that red doesn't mean go in a lot of cases, and that's actually against the fire code, because if you put a red button on the wall, it has to be connected to the fire alarm. So we're working through that. But I think that he couldn't have spelled it out any clearer. In these systems, people are doing one thing over and over and over and doing the rest of it the rest of the time. Why make them pick up the two 30-button remote controls to do that one thing? Judy.
Just as a follow-on, there's a really nice set of some research from Rank Xerox Europark, probably in the early 90s, called the Buttons Project.
Mm-hmm.
So you build a button that does all the workflow. If you're confident with that, you can open up the button and see various components there and change those. Or if you're really wanting to mess around with that, you get into a list of layers you can go through depending on what your scale of skill is. And something like that can be done here.
And so that reminds me, one of the things that we're looking at is sort of the next generation of this, stick a button on the wall thing, is a way to have that remote control device programmable and you can take it out of the room. So that effectively is a key to a virtual space. Just as you could give someone a key to get into the conference room, that's a programmable key that if someone has made a reservation to that room, they've given the address they want to connect to the help desk earlier in the day, then they can just get a key fob of some sort. They walk in, they put it in the right place, and everything happens that's supposed to happen.
A remote control. The moment they pick it up, the system automatically comes on and it remembers the last address call and the address goes to that right away. So one button calls and you're up and running. For the 90% case, for the 10% case, you know what to do. These environments have been really engineered, and partly we can do that because a whole bunch of people who used to actually go staff those rooms and paying all this salary to a lot of people all across the country or around the world to do that, and they realize that there's money they can save by really engineering them. But to really engineer them means that they all have to do the same. I mean, they're all using the same equipment and the same infrastructure on that. So I think the standardization behind really achieving this kind of vision is it's not going to work if you only can just do one office.
Right. And you said two things which were interesting. One is that they all have to be the same, but it's a standardization that's important. And I think that there's an opportunity here in this sort of deployment and design space to do some standards work so they don't all have to be the same, but they can talk to each other. And I think that we need to look at these sort of deployment and control problems as areas of research for advanced collaborative environments, because it's not a matter of, this is just the setup that's required at each part. I think there's some really interesting research opportunities in this space. No question for you.